Good evening and welcome to the Canberra AWS user group. I'd like to begin by acknowledging the traditional custodians of the land we're presenting from, the Ngunnawal people, and pay my respects to their elders, past and present. So here we are again, March 2022, and more of our, and I'm well all over the slides already. Another fantastic lineup of AWS content for you this evening. So we're going to go through some of the what's new in AWS this month, tell you about some of the white papers that have been released. And then our main presentation this evening is Andra Christie, who's going to talk to us about digital twins in AWS. But before we kicked off, I did want to take a minute to just sort of acknowledge that March is the month where we have International Women's Day. And here in the Canberra AWS user group, inclusion and diversity is a really key part of the I suppose, how we want to build this community, particularly when we get back to in-person events. But I just wanted to take a moment to really sort of stop and acknowledge some of this stuff in that, individually, we're all responsible for our own thoughts and our own actions all day, every day. And for that reason, we're the ones who can break the bias in our workplaces. We can break the bias in our communities. We can break the bias in our schools and our universities. And so together, we can all break the bias on International Women's Day and beyond and start to improve things for women. Whether deliberate or unconscious, this kind of bias makes it really difficult for women to move ahead. And just knowing about the bias isn't enough. It takes action to make a change. And so my ask of everyone who's watching this online and who's going to participate in our user group is to take action. So this year, everybody made the symbol of crossing their arms to show solidarity for International Women's Day here, and to ultimately call out people who are having gender bias and making gender discrimination and stereotyping. Calling people out on it every time you see it. Are you in, is the question. And here at the Canberra AWS user group, we definitely are, and wanted to make a point of calling that one out. Alrighty, into the usual content as well. So I'd like to draw people's attention back to our YouTube channel. If you didn't know it exists, go and look it up. We've got our back catalogue of the last 2 years worth of content there, and you can go and look at it all on demand at your own leisure. All right, so let's talk about what's new in AWS this month. So we've got 108 new features and releases this month so far, only the last day or so of the month to go now, but let's go through, well, again, in a graph, because who doesn't love data? But let's go through some of the ones that I wanted to call out and have a bit of a conversation about. So the first one is that AWS has launched a customer carbon footprint tool. Right, JJ's telling me the slides are really slow on the stream and still transitioning. That's moderately interesting. Okay, good. Technical issues every single month. I'm going to keep talking on this, and you can just listen to what I'm talking about, and we'll edit this in the YouTube video. It's going to be fine. And if you're watching this on YouTube, it means I've left this bit in. All right. So AWS launched a customer carbon footprint tool. So what this is about is being able to really understand the impact of your workloads in terms of carbon that's being emitted into the atmosphere. So being in a cloud ecosystem, sometimes that's a little bit harder for you to be able to directly understand. You don't see the electricity bills for the data centers. So getting a really good feeling for that isn't something you can easily do. With this new tool, you can go into the console and have a look at the carbon footprint of your applications and your workloads. And that also is able to factor in things like the work that we're doing in terms of renewable energy and what impact that has on your carbon footprint as well. So if you hadn't seen it recently, we added a sustainability pillar to the well-architected framework. And so this acts as a really great source of data to leverage into looking at sustainability of your workloads in the cloud. Next, AWS Fault Injection Simulator now supports task-level faults for the Amazon Elastic Container Service. So ECS is a really great way to run containers in the cloud. And what Fault Injection Simulator does is lets you essentially create specific faults in your applications and workloads so that you can test things like your application resilience. For example, I could terminate particular tasks in my ECS cluster and see if my auto-scaling automatically reprovisions them and observe how my application behaves while it's going through those faults. So this is a really great way to test what you've designed for in terms of what you expect around like faults and things that could go wrong in your application. Next, Amazon RDS now has a new multi-AZ option for MySQL and Postgres databases. And this new mode allows you to have up to 2 times faster commit latency, automated failovers that will typically take place in under 35 seconds, and also to have a readable standby instance, where previously the standbys were non-readable, so you had to work with just the primary. So this is basically the result of a lot of great work the RDS team has done in terms of how we can architect and improve the system on behalf of our customers. So if you're using Postgres or MySQL, definitely go in and have a look at this new multi-AZ configuration and see what benefit it can provide to your application. Now I'm just going to pause here for a moment because I have a feeling JJ is going to tell me that that slide's taken its time coming through, and I'm going to edit this out in the YouTube. You people can't see this on the screen, but JJ is going like this at the screen. All right. Next, Amazon EventBridge has launched enhanced rule filtering and event transformation capabilities in the management console. So what this means is if you've been using EventBridge, it's really good at being able to filter out particular events for things like replays or to be able to transform events to send them onto specific targets. This was all previously very doable with things like the command line interface or CloudFormation. Now you can get a lot of that extra functionality in the console directly, so you don't need to interact with a programmatic tool to get to that functionality. Next, AWS Lambda has announced support for the principal org ID in resource-based policies. Now, what this means is it's really easy to specifically say that your Lambda function can be called by anywhere within your organization, as opposed to having to list specific account IDs. So this makes it really easy to have common functions that can be run to do things like automatic remediation or reporting on things in a cross-account fashion without having to keep a list of accounts up to date in that policy. It also means your IAM policy there is going to be much easier to understand. Next one is AWS App Config feature flags are now generally available. So feature flags is a really common concept that developers use when publishing pieces of code to be able to turn on a specific feature or not. So it really makes sense if you've got like a continuous integration, continuous delivery mechanism where you're constantly releasing code to production. When you're ready for that big 9 a.m. press release with your new feature and new version going live, rather than waiting on code to deploy, you can toggle a feature to say turn the thing on. App Config has a really great set of mechanisms for this that allow you to control those feature flags in the AWS console and have them take effect in your applications. And it's now generally available after being in preview for a little while. So definitely check that one out. Next, AWS has announced the AWS Billing Conductor. So the Billing Conductor is a new tool that essentially is designed to help you provide chargeback and showback of AWS costs to child accounts within your organization. So you can do things here like add shared costs or add specific discounts and things to this so that your consumers can see an exact cost the way that you want them to see it. So if you've got a system where you've got some sort of showback or chargeback within your organization so people can have a clear understanding of what their costs are, this can really let you tailor that experience to make sure that people are aware of exactly what those costs are to them. Next, AWS Lambda, another Lambda update, now allows customers to configure up to 10 gigabytes of ephemeral storage for Lambda functions. Now, as a big old developer, this is one of my favorites for the month. Previously, Lambda let you have 512 megabytes of ephemeral storage, which was okay if you needed to do a few things, but customers who needed to use Lambda to process large elements of data would typically have to go back to using either S3 or the Elastic file system. Now, with 10 gigabytes of ephemeral storage, you can bring much more data into that Lambda environment and process it in place without having to use external storage mechanisms, which ultimately means you can work with the data faster. Next one, Amazon Route 53 Resolver DNS Firewall has significantly reduced its service costs. So if you've not looked at it, the Route 53 Resolver DNS Firewall service lets you control how DNS is going to be resolved in your VPC by using inclusion and exclusion lists to be able to control what is able to be resolved by instances in your VPC. Now with this new pricing model, customers are able to essentially get the same functionality for less with a change in the pricing and a change where we see increased usage. You'll get additional discounts there as well. And the last one I wanted to talk about this month was an update to Amazon Kendra. They've released an FSX connector to enable intelligent search on Amazon FSX for Windows File Server. So to unpack what all of that means, FSX for Windows File Server is a managed service that lets you run Windows file servers in a completely managed way. So I don't need to choose how many servers and scale them. I just set up my file shares and control who can have access to them. So it's a really great way to have a completely native Windows file system in the cloud. Now, Amazon Kendra is able to directly connect to that to crawl my content and make it available for search to users who would like to be able to search for content using native questions and asking questions about the content, such as, how do I take leave? What's the policy on X, Y, or Z? Kendra can search through the relevant documents and provide meaningful answers to your users, and now do it really easily with content that's stored in FSX for Windows. Now, in terms of white papers that have been released and updated this month, fairly quiet month. There was only 5 in total, but there's a couple that I wanted to specifically call out. First of all, the Advanced Multi-AZ Resilience Patterns white paper. So this is a brand new white paper that talks to more advanced patterns of how we can do multiple availability zone resilience of your applications. So we'll get into the weeds around how to improve and track and action things like your recovery point objectives and recovery time objectives, and really work to some architectures there to improve those. Next was the best practices for migrating from relational database management systems to Amazon DynamoDB. So if you've got an on-prem relational database of some description and you're interested in moving to a NoSQL database like Dynamo, this white paper's got a whole lot of really great tips and tricks and things to look out for when going through that kind of migration. And lastly, as an update, to the building a scalable and secure multi-VPC AWS network infrastructure, because who doesn't love more networking? But enough from me. On that note, I'm going to hand over to this evening's main presenter, which is Andra Christie, and she's going to talk to us about digital twins on AWS. Stay with us for just a moment and we'll be right back.
Good evening, everyone. It's really great to be here with you. My name is Andra Christie, and I'm a specialist solution architect in the public sector. And for more than the last year and a half, I've focused pretty much exclusively on digital twin functionality. And I was really excited when we announced TwinMaker last year. So before I get started, TwinMaker was really designed, in my opinion, to bridge the gap between customers who didn't want to start from scratch in building their digital twins, and also customers who didn't necessarily want to invest a heap of time in customizing an existing digital twin solution to actually meet their needs. So without further delay, I'll jump in and I'll cover TwinMaker's capabilities, what it's capable of doing today, and I've also got a small demo. So there are a lot of interpretations out there, but simply put, digital twins are virtual representations of physical objects and processes that very closely mimic the state and behavior of physical counterparts. But more importantly, they're built specifically to solve business challenges. Customers are using digital twins to get better visibility into their operations. They're using analytics on the digital twin to generate insights, and then they're applying those to the physical world to drive improvements. Worthwhile mentioning that digital twins are not necessarily a new concept, They've actually been around for a long time, but what makes them relevant now is we've got more and more customers across industries focusing on digital transformation. They're using more advanced technologies like graph databases. There's a much broader adoption of IoT and machine learning. And of course, cloud computing in general has made digital twins not just possible, but within reach for all of our customers. And if we kind of go back to solving specific business challenges, nobody wants to create digital twins just for the sake of it, because it's actually really hard. So the first question that we always focus on is, what's the outcome that you're working towards? Because that's the only way to define the problem and then to solve the problem. So to help our customers navigate the space, we've actually developed a digital twin index using levels 1 through to 4. This is very similar to what you'll see in the self-driving car space. They've got a leveling system there from 1 through to 5. So, level 1 would be cruise control, level 2 would be adaptive cruise, then all the way to level 5, where you've got that truly autonomous driving, the hands-off, no steering wheel kind of situation. And each level drives their own business value just depending on the use case. So as a customer, by understanding what levels your specific use case represent, it kind of helps you to understand the services that you need to be using, the underlying data that you need, and then you can also see how others have kind of tackled similar use cases and deploy them for their benefit. So let me just take you through each of the levels very quickly. So level 1 would focus on describing the structure of the physical system. And historically, this would be represented by things like 3D CAD models or engineering simulations. So for example, one of our partners offers their simulation software that's used to optimize the layout of wind turbines across wind farms. And this minimizes weight losses and maximizes wind energy production, which can potentially result in millions of dollars of additional revenue. If we take this a step further, what if we can connect some version of these engineering models directly to the customer? So, think about a community town hall meeting where you're using augmented reality to actually see the aesthetic impact of, say, a new wind turbine being proposed on top of a hill. Or as a customer, going to buy a car, being able to select from a really wide range of, color features and trim options, and being able to experience that digitally. And then, of course, this can be used for immersive virtual world training style scenarios. Level 2 focuses on connectivity. So this is integrating the IoT sensor data, the maintenance data into a dashboard. And the goal here is to understand the present state of the physical system. Now, in the industrial world, this is not anything new. We've had wind farm power plants, factories that have been using real-time monitoring systems for a long time now. But again, if we elevate this, and rather than having a static 2D screen, we take it through that immersive 3D world, and you can, imagine walking around your factory floor virtually from any remote location. You could have a service engineer remotely beam what they're seeing with their eyes to a remote expert who can then provide further guidance. And although this sounds slightly futuristic, it's actually happening today. Another one of our customers, Scope AR, is actually providing this augmented reality visual knowledge capability to customers in aerospace, in the energy and manufacturing, and also in the healthcare industries. So finally, level 3 is where we start to focus on using prediction models. So you're integrating machine learning and other prediction models to emulate the behavior of the system. So for example, a virtual sensor that's modeling the behavior of a gas turbine engine in an airplane to predict the combustion temperature, because it's not possible to measure the temperature directly, it's just too hot. And again, this is typically the realm of asset performance management. So what you're really focusing on is improving the operations and preventative maintenance, but there's a ton of other use cases. So you can have forecasting on things like weather, forecasting fraud detection, even yield predictions. And a really unique example is actually in the agricultural commodity markets. We're supporting another customer, Descartes Labs, and they use satellite imagery to analyze crop health at continental scale. And the forecasts are actually used by the end customers to decide the best hedging and trading strategy. And again, this can easily translate into millions of dollars worth of savings or trading profits. I said finally prematurely because I realized I still had one level to go, but finally, the last level is level 4, and this is the living digital twin. And this is where we use updatable predictive models to enable us to kind of do that utopia what if analysis. And if I were to talk about the key distinction between level 3 and level 4, it's the ability to update parameters on the model itself based on the operational data, and then to be able to do that at scale for potentially hundreds of thousands of assets. If you take the car example, you know, if we've got 100,000 cars driving out there, we'll have 100,000 digital twins, because each car is driven very differently. Its behavior is going to be very different. Certainly if I'm driving it, it will be. You know, a level 4 digital twin would update itself on a very regular basis to reflect the wear and tear on that actual entity. So when it makes a prediction, it's making a prediction on, you know, when a part might break or what the efficiency might be. And these are truly relevant predictions to that specific car or wind turbine or, you know, whatever it is, based on its state of operation as of today. So the TwinMaker product team spoke to a lot of customers across many different industries, and they shared with us a lot of interesting and innovative use cases. And what we found was that a large number of customers were focused on applying digital twins to transform their operations. And, you know, whether it's manufacturing, smart buildings, power and utilities, energy, it's not really an exhaustive list of the industries, but the real question was, why are customers not realizing the value of digital twins? And as I mentioned before, well, it's really hard. Customers know that building and managing digital twins can be both time consuming, it can be complicated, costly, they'll need specialized skills. They need to combine data sources from different sources. They need to generate live insights. They need to create contextualized visualizations. And, you know, all of these things can be quite complex and difficult to achieve. And there were really three main areas that came up time and again in discussions with customers. And firstly, it was the fact that digital twins have data that lives in, you know, many different locations. So it's potentially difficult to curate and create associations. Then, you know, physical assets can live and evolve over many years, decades really, and digital twins need to be able to do the same in order to be relevant. And finally, those 3D visualizations that give us that natural look and feel for, you know, humans to actually interpret operational data, they're also complex to build. So there's a lot to kind of unpack there. That's why a lot of customers who wanted to get into building digital twins have traditionally shied away due to that perceived complexity of it all. So this helped us with the key functionality and the key pain points that we wanted to address with TwinMaker. So TwinMaker, for anyone that doesn't know yet, is a new service that was launched at our reInvent conference last year. It's currently in preview in 4 regions. And as the name implies, it's a service that's meant to help customers easily create digital twins of the real world and then use them to optimize their operations. So the way it does that is by connecting data sources from really diverse, you know, it could be equipment sources, it could be video cameras, it could be business applications. And then it creates a knowledge graph to model real world systems to generate real-time insights from the digital twin. So customers can create digital twins of their physical environment, and then they can use 3D visualizations to build applications that, for example, help plant operators or maintenance engineers really optimize their operations, potentially increase production output, increase operational health and safety, improve equipment performance, you know, lots of things that you can take away there. Probably the most important thing to keep in mind is that TwinMaker is a set of tools. It's not an end application. So it's a tool for building digital twins. I've got a quick customer use case. So Invista is one of our launch customers, and they've been working closely with us for a number of years. They built a strong analytics and data science capability. And what they were really looking to achieve was they've got a lot of field personnel that needed to address operational notifications from the plant floor, but their equipment information was distributed across many different systems. So by using TwinMaker, they built a digital twin of their manufacturing operations into what they called their connected worker application. And this brings all that disparate information into a single pane consolidated view that represents their real world environment. So this has improved productivity, it supports environmental health and safety, and it really lets those employees focus their expertise on different things rather than having to run and figure out where that faulty piece of equipment is. Another launch customer is Carrier. they're using TwinMaker with their Abound Smart platform, and they're using TwinMaker to create digital twins. This is basically for real-time and historical state of buildings. So this is all about improving occupancy comfort and energy efficiency. So, you know, they were able to increase visibility into performance trends. They were able to yield more reliable uptime with their predictive maintenance. They were able to decrease service costs, and they were able to run equipment more efficiently. So some of the top use cases that we focused on, as was sort of proven by the customer use cases that I discussed, were improving field operations in things like manufacturing plants, so that field techs and operators have all the info in a single consolidated view. A really popular one is increasing equipment uptime in remote facilities. So if you're able to get that view, you know, that 3D immersive view of what things look like in the real world, it potentially enables you to remotely diagnose equipment issues. You've got immediate access to all the relevant operational data, so you can make decisions a lot faster. And then, as the last example that I showed, you know, enhance tenant experience, achieve sustainability goals in commercial buildings, and probably a lot more. So if we get into how TwinMaker actually works, this is the closest that I've got to an architectural diagram. So it's got a plug-in architecture, and it lets customers connect to data sources like real-time IoT sensor data, or 3D data, or point clouds, video data from cameras, any sort of application data without having to re-ingest it. That's a really key part. Then you connect to those data sources with the plug-in architecture that's modeled into a knowledge graph. And that knowledge graph is also sort of overlaid on top of the visual 3D model, such that the visualization layer has a layer of widgets that connect back to the knowledge graph and all the data sources connected to it. And then you could surface that to the end users via a web application. So that's kind of the high level of how that works. Again, keep in mind that TwinMaker is not the end user application. It's a tool for building digital twins. If I think about how long it took one of our customers, Woodside, it took them, I think, about maybe 2 years to build a digital twin on AWS. And, you know, we want customers to be able to use TwinMakers to, you know, build their own digital twins in maybe half or much less than that time. And as I said, we're not asking customers to move their data or re-ingest it in any way. We're just associating the data we have, or the data they have, with the model that we create. And that also means that the model is dynamically updated. So when we create a 3D view, it also updates the changes in the end user application. There are 4 key pillars to TwinMaker, and I'll talk about them in the next few slides. We've got the data connector first. So the data connector allows you to basically connect to all of those data sources wherever they might live. The motivation behind this was to allow not just greenfield but brownfields customers to jump into the mix and kind of create a federated interface that acts like an abstraction over the underlying data sources. So it fuses data from IoT sensors, cameras, documents, maintenance history, other context setting and business applications, and it's able to fuse context between all these different data sources. And as I mentioned before, it creates a knowledge graph using these data sources. We've also got a number of connectors that come built in with AWS services. So we've got out-of-the-box connectors for Sitewise. For anyone not familiar with Sitewise, it's a service that stores industrial IoT data. There's connectors to Kinesis video streams, so you can ingest and store video data and also have live and historical playback. We've got connectors to S3, and obviously there's a heap more data sources, and we'll be adding more of them, but at the same time, we wanted to provide customers with the ability to create their own connectors. So we've got a really flexible framework that lets you write your own data connectors to data sources that you're using, basically using Lambda under the covers. We've got samples available for data sources like TimeStream, Siemens MindSphere, as well as Snowflake. I think we've got one coming out for OSI PyHistorian. So you can easily take these connectors using the custom connector framework, apply them to any data source that you want to connect to your digital twins. And I've got later on a GitHub link to share where you can see, you know, the demo that I've created, as well as the samples for some of these data sources. Next, we'll talk about the model builder, and this is how you describe the relationships and data properties for the digital twin. If you're familiar with game development, it kind of embraces that entity component architecture. And, you know, as the team was talking to customers, they kind of realized it was a very good fit for modeling digital twins as well. So simplistically, what the architecture allows us to do is model elements in the environment as entities, and this can be equipment, it can be processes, people, spaces, and then you attach various components to that entity, and that component brings context to the entity. So based on the state that each of those components is in, it drives the behavior for the entity that they're attached to. So all of those data connectors that I talked about in my previous slide are basically components that you attach to entities. And as I said, these can be equipment, assembly lines, processes that you want to model. So it's a really flexible way to build out the digital twin model into a knowledge graph. And this knowledge graph is essentially common metadata that connects the dots between these different pieces. And what this common metadata or knowledge graph allows us to do is provide a single unified API on top of the knowledge graph that essentially removes that heavy lifting. So, you know, when you're querying data, all you have to do is call the TwinMaker API and kind of say, hey, I want the data for this entity from this time to this time. And all of the complexity of knowing where the data lives, the data store it's in, and how to query that particular data store is actually abstracted away. So that's a really powerful way to use those simple APIs. The other really great thing is that the common metadata lets us put these data streams on a common timeline. So it means you've got the power to rewind time and see the state of your environment or your facility at that particular point in time. And rewinding back in time doesn't just do that on a data stream per stream basis. It essentially rewinds time across all your data. So as I said, you can truly see the state of your environment in the past. At the heart of a lot of what's been done with TwinMaker is about making change management easy, because we know that physical spaces and physical environments change all the time. And with this model builder, as operations mature, as you know, customers start to collect different types of data or new data streams, what that looks like is you're adding additional components to the same entities without having to redo the graph. So it's really easy to keep the knowledge graphs up to date, and as things progress, bring those improvements into the virtual digital twin as well. And then we've got the Scene Composer. So Scene Composer lets you create those 3D spatial representations of your environment with widgets for data. We've really embraced importing existing models to create visualizations. So we really want customers to be able to reuse the existing CAD or BIM or 3D modeling that they've invested in. And then all they need to do is convert them into GLTF format. Now quickly, the reason we've embraced GLTF is it's lightweight, it's open source, there's no licensing, so it's just very easy to get started using it. It's also been optimized for the web. So Scene Composer, it's a really simple composition tool, which you'll see shortly in the demo. It doesn't have all of the advanced features of a 3D editor, but that's because its purpose isn't to create 3D models from scratch. So it's really a composition tool that lets you place and position different types of equipment into the same scene, so you can compose an environment that really mimics the physical world. And once you've got that base scene created, you can add data overlays. So data overlays are just widgets that you add on top of your scenes, and they connect back to the data that you've modeled in the knowledge graph. And you can add tags that connect back to time series data. You can define simple rules to tell you that the visual for those annotations need to change as the data changes. So as a simple example, if temperature exceeds 50 is a rule that you've configured, you can easily see that it changes in real time to depict that in the particular component, either with a red tag, or you can make it turn red, or however you want to manifest that. And you can determine that that equipment needs some attention. And again, we've made it easy to manage change, and that's possible because of that composition nature of these scenes. So if you think about a piece of equipment that needs to move from one room to another, you don't need to create a monolithic model from scratch. All you have to do is select that piece of equipment and move it. and then you've got a new version of the scene and you can move forward from there. And the last thing is the application toolkit. So this is how we want developers to be able to create end user applications really fast. We've got a plugin application or an application plugin for Grafana. This is both open source self-managed Grafana on an EC2 instance or Amazon managed Grafana. So if you want to not have the heavy lifting of managing and spinning up your own instances, managed Grafana is the way to go. It's based on the front-end developer SDK. We wanted to make that available for both customers and partners to extend these digital twins into their own custom applications. And we wanted it to be really flexible and open source. We're also embracing open source a lot more because there's so much innovation happening in the digital twin space. We also wanted to make sure that there's a place where we're constantly adding samples and tutorials and instructions on how you can create digital twins. And I've mentioned the GitHub repo before. That stores all of that sample code and the tutorials that we've got available today, which I'll share with you after this session if anyone's interested. Very quickly, we've got a number of launch partners as well, everything from software and hardware partners to consulting partners, as well as partners that focus on modeling, simulation, and visualization if you want to push the boundaries of what can be achieved with just TwinMaker today, and you want to extend it to that, potentially level 4 style digital twin. That's all possible as well. So just before I jump into the demo, and I might skip this because I'm going to take up too much time, and I'm just going to jump into the demo. Okay. All right. Please bear with me, as I'm sure it's probably logged me out, but let's see how we go. And as I said, TwinMaker is still in preview and available in 4 different regions. And the demo that I've already deployed is based on what we call cookie factory. So it's a representation of a cookie factory with all of its equipment like cookie lines and mixers. And as you can see, it's currently in preview, no problem. So we'll start off with the workspaces. So a workspace, you can think of it as essentially an S3 bucket with an execution role attached to it for now. And I've got a few workspaces. Some are more built out than others, but we'll start with Cookie Factory, and I'll take you through the components. So the component types, these are the data sources that I mentioned, and you can have multiple component types. You can sort them by predefined and user-defined, and the user-defined are the ones that are not native. So this is just a JSON document, and if I just scroll down and I actually find the flag, and I'm conscious of not going too fast either, but you can see here the is native flag is set to false. So, if that's the case, we've got to specify a Lambda that's going to provide the data for this particular component. And as I said, there's examples of these components via those JSON documents on GitHub as well. So you'll be able to see exactly how this works. Moving on to entities. So this is where we create that knowledge graph. So in here you can see we've got spaces, we've got the factory rooms themselves, we've got the equipment, a large number of mixers, cookie lines, and if I were to select a particular mixer, at the moment, obviously because it's a demo, I'm pulling in simulated data. But I can also add additional components, and if I've configured, site-wise or S3 or telemetry data sources, I can add them all in there. So I can add a component to a particular mixer. I can select it from the list and configure it as needed. And then we've got the resource library. So this is where we've got all of the assets that we use to create a scene. So you can see we've got a number of GLB files, which is basically the binary version of GLTF. So we've got the cookie factory environment and then the various entities, the water tank, the mixer, the cookie lines. Now, these have been created elsewhere. So it could be, created in Unity or Unreal or Blender. And you export them out, you convert them to GLTF and import them into TwinMaker to be used. Most of the proper 3D editors have got conversion utilities. So you can convert from whatever's the native format into something like GLTF. So it's pretty easy to do. And moving on to the scene itself, hopefully this will load okay for everyone. So as it's okay, of course, just bear with me. And come on, do your thing. Now, remember that this is essentially where you build out the digital twin, so it won't be the final representation. I've also got the Grafana demo, which is essentially the representation of that low-code end user application that I mentioned. And I've got also a continuous Grafana demo, and that's what I'm actually going to show you. If you don't want to go to the trouble of deploying this cookie factory yourself, which I would actually highly recommend because it only takes about an hour to do and you can play around with it a lot more. But if you don't have the time or inclination, you can just go to the Grafana continuous demo, and I'll show you the link to that in a moment. So this is the cookie factory, and if you can see those blue dots and tags, I'll talk about those in a minute. But what I can do is I can control my scene. So I can slowly move into the scene by panning the camera angles. I'm moving into the mixer room, and I might just change my camera angle and I can sort of tilt it. I can move around. I can really get a good idea of the entire 3D space. And you can see this works really well for like a physical space like a factory or a building. Obviously you can apply it to many other things as well, but I think this this demonstrates really well what a particular physical space with its various entities looks like. So what I can do from here is, you can see this is very similar to that knowledge graph that I talked about before, because it is. And I can go to particular pieces of equipment and I can add rules and tags to determine how they might behave. So if I want to add, now again, I've got a few pre-configured rules here, but you can create your own rules. So if we look at one of the predefined ones, and I picked the simple color one. So if the temperature of this particular piece of equipment that I'm monitoring goes to over 100, we want the tag to change to red or yellow. And that's what I'll show you will actually change in the end user application. Now, this UI is not yet an end user UI. It's intended for someone who's fairly familiar with plotting a 3D interface, who can zoom in, place data in its right location, and so on. So if I go back and I want to monitor additional things, so it could be temperature, it could be RPM, it could be power. I can add different tags and map them to different components and alarms to be shown in a specific way in the live scene. I can add additional 3D models, I can add light, I can add a model shader, I can translate the objects themselves, or I can move them around, I can scale them down. So there is a lot of flexibility that you can do, even though this is a fairly, I would say, not rudimentary, but it's, as I mentioned before, it doesn't have the bells and whistles that you might get with a proper 3D editor, because, again, as I mentioned, it's not supposed to. So that's just a very, very quick overview of the TwinMaker interface. I'll just quickly show you the Grafana continuous demo. And as I said, obviously, this is the demo that's continuously running, and it's based on the cookie factory as well. So one trick is to set it to the last 3 hours because that actually gives me the data that I want to see. But it shows you the telemetry for all of the various mixes. I can go into the alarm history and have a look at how this was behaving over that specific time frame. I can have a look at things like RPM data and really draw in and granularly see what happened at that particular point in time, if I'm so inclined. And you can basically add dashboards and map them to whatever you want to see by querying TwinMaker directly. So it's got a pool model, and that's based on those unified APIs that I mentioned. And it also pulls in the scene from Scene Viewer. So it's loading that same data, but instead of seeing just all of those blue tags, you'll actually see, once the scene loads, that in here, we'll also see a few red tags because we've set some rules and that equipment is not behaving as it should, and it needs some attention. So, we can send someone to the factory floor to actually have a look at what's wrong, or if we've deployed a more sophisticated style of digital twin, we can also remotely control it and potentially not have to send anyone there at all. Okay, so it's still loading. Come on, load my scene. If I'm clicking on a particular entity, when I scroll down to the scene, it should take me to that specific mixer. So if I just zoom out, as I said, you won't have the same level of controls that you do within the scene composer itself, because obviously we're not building out the scene here. But if I press V and kind of scroll out, you can see there's a bunch of the mixes that require our attention. In fact, probably more than, oops, sorry about that, probably more than we would like. But in any case, now that we know that there's a bunch of them that require our attention, we can obviously implement mitigation measures as well. And the other thing, which for some reason isn't working, we've got a camera feed as well, which usually when it is working, when I'm setting it to my cheat 3-hour mode, I'll try again. Basically, you can see that a certain component has a scene by relationship with that camera. So it comes really handy if, for example, one of those mixes has malfunctioned, and you can rewind and see what happened in the last hour. Maybe Bob the worker dropped a pallet onto it and that's why it's not working. So another really good way to kind of see that, root cause analysis of either seeing the live video or actually going back in time. So, this is just an example that can showcase some of the current capabilities of TwinMaker. As I said, this is all available in the GitHub TwinMaker samples repository. Actually doing this demo end to end, I think I mentioned, takes about an hour. If anyone's interested, I've got some tips for how you can reduce that time to about 30 minutes. And it's really easy to sort of go from zero to having all those full visualizations in Grafana. It all works. I've tested it out a bunch of times. And on that note, I hope this has given you a good overview of what you can expect with TwinMaker currently. And I really appreciate your time, and I hope this has been a useful session. I would like to now pass back over to Brian. Thanks so much again.
Thank you so much, Andra, for that awesome presentation. There's definitely a few things in there that I've learned, and I need to go and have a look at that Grafana dashboard too. So, as always, to wrap up, we like to ask you all, what do you want to hear? If you've got particular topics about AWS that you're interested in hearing about, make sure you reach out and let us know, either through the chat here in Twitch, through messages in Meetup, or comments on our YouTube videos. We're keeping an eye on them all. Also, if you've got something that you want to present about, definitely reach out to us. You know, it only needs to go for 5 or 10 minutes just to talk about something cool that you learned about AWS or something that you want to share. Would very much so love to hear from people who are interested in sharing some of their learnings with the group. As always, submit your feedback. If you registered through Meetup for this event, you should get a little notification that says, hey, tell us what you thought. It's just a quick 1 to 5 star rating with a couple of quick options as well. We check it every month, and it really helps us make sure that we're bringing you content that you're actually interested in. And lastly, as always, friends don't let friends miss the Canberra AWS user group. Word of mouth is always our best mechanism for sharing what we do here. So if you like what you've seen tonight, send links to our YouTube channel, send links to our Twitch, to our Meetup, and let other people know so that we can continue to grow this community. Thank you so much for spending your night with us. Hopefully you found it interesting and learned a few things. We'll be back again next month with more AWS goodness. Good night.